thanks for inviting me here today. I was here a few years ago and gave a presentation on cell processors, and our discussion was about how we were trying to integrate high-performance computing technologies into System Z. And I participated in the early design discussions along with Peter Jochen, who's here, and Jeff Fry, in helping to define what became zEnterprise, where we have this essentially heterogeneous environment of servers centered around System Z that are managed together as a unit, so to speak. And my responsibility was, how do we get high-performance computing technologies into that structure? So you'll see that this presentation, in very many ways, is an evolution of some of those early thoughts. A lot has changed between then and now. One other comment I'll make is, as we talk about analytics, is this is a very, very broad field. I'm going to attempt to kind of scope it out and talk about the different aspects of it and how we look at those different aspects and then try to determine from an infrastructure point of view, from the server hardware perspective, from the operating system, and from the middleware and software perspective, how we can optimize the analytics. But I imagine many of you in the room, but maybe not some of the students, remember what we called The Graduate back in the 60s. And a young man, Dustin Hoffman, at that time, was told, plastics. Go into plastics. Well, my advice is go into analytics. This is really a hot new area in the industry, and a lot is going on. So I'm going to try to talk about what business analytics is, kind of System Z, business analytics, and high-performance computing, and what are the challenges for customers, what our challenges are from a zEnterprise perspective, and then I'm going to gradually, through the presentation, work up towards this idea of a zEnterprise Analytics Hub. What are the various components that need to go into that? And then I'm going to talk about real-time analytics. And real-time, I really should put in quotes because that's also a misused phrase, and what does real-time really mean? But I'll talk about some of the things that we're doing to certainly try to provide predictive analytic feedback to the business to make a predictive business as quickly as possible. So within IBM, whenever I talk about analytics, I have to negotiate with my peers about what it is that they think they're talking about, and the same when I talk to customers. And I found this chart here to be extremely useful in helping us to figure out exactly what area of analytics that we're focused on. And this comes from a textbook, kind of the textbook on analytics by Davenport and Harris, which I highly recommend. But if you take a look at this taxonomy in the bottom left and work your way up, you see standard reporting, ad hoc reporting, query drill down. And these are technologies and processes where you're really looking at what happened, where did it happen, how often did it happen, this you can think of as a reporting environment. And most of our customers have been doing this for a long time. Data warehousing, data mining comes into this space. And this is pretty well established in businesses. And when I look at it from a Z guy, from a Z lab perspective and from a design perspective, what I see is an environment that is largely very data intensive. And System Z certainly has been developed in many ways to handle data intensive environments. Now, as we move up the taxonomy, we start to look at alerts. So when certain things have happened a certain number of times, maybe when you want to set a flag and now kick off a process. And maybe there's some rules to decide based on what's happened and how many times it's happened over what period of time. You might do one action or another action. So you start to get into business rules here. You also get into business process management as part of that. And then you work your way up. You start to look at forecasting and trending, and then to what-if simulation, and then you start to work your way towards predictive modeling based on what you know about one group of people, what might another group of people that you don't know so much about do in the future. And that's where we have products now in the portfolio like SPSS that IBM purchased, and I'll talk more about that in a little bit. that get us into the predictive modeling space. You work your way further up, you get into what's called optimization, and that's more in the operations research kind of area, but you see things like supply chain management, scheduling, truck routes, airline flight crews, and so forth, optimizing many variables that all have their own individual constraints, and figuring out how to take all those different resources you have and the constraints that you have within each pool of resources and make the most efficient solution out of those different variables. So iLog is a product that IBM has that does that. And then you get further up into task optimization, which I haven't looked as closely at yet. But this gets into the area which at least the academics are referring to as analytics. And if you break it down, you get into prescriptive or predictive analytics. And when I look at it and I go, gee, as I work my way up, I'm starting now to get into areas that are very numerically intensive. And so these numerically intensive activities all have a dependency on these data-intensive activities. And so now the challenge for zEnterprise becomes, how do we essentially integrate these capabilities together and find the right balances and so forth. And this is where it was interesting, because my work on the cell processor, we were very much focused on this numerically intensive environment. And at the time, this is 5 years ago now, when I went out to some of our banking customers, for instance, and I say, hey, do you do any high-performance computing? And the commercial retail bank guys would say, not us. You got to go talk to the investment banking guys. They're the ones who are doing the Monte Carlo simulations and all that. So I go over and for algorithmic trading. So I go over and say, hey, you do any high-performance computing? And they say yes, but we have no interest in System Z. We're all x86 clusters and all kinds of exotic hand-built configurations. And so at that point in time, there was a big separation between kind of your commercial processing environment and your high-performance computing processing environments. But I was starting to see that as I talked to more and more customers, that those areas were going to start to converge. And so it was really just a question of time before that happened. And perhaps what I was trying to do with Cell in the zEnterprise environment may have been a little bit early. Now, then, shortly, somewhere along there, my management asked me to take a look at business analytics. And when I looked at business analytics and I started to see things like predictive modeling and optimization and what was really under the covers of that, I said, this is where it comes together. So this is where you're going to see, and I'll talk about this more, where high-performance computing requirements, commercial computing requirements are going to need to start to merge. One other point I want to make on this is, despite the academic taxonomy here, from my perspective, anything that you do to try to derive more value from your operational data is analytics. So anything in this spectrum fits the definition. So here are 7 key functional areas that we see actually in the SPSS environment where predictive analytics is used. Cross-selling, direct marketing, collection analytics, what's the possibility? Are these customers going to pay up? Are they going to default on loans? Portfolio prediction, that can be private wealth management stuff in the commercial side, or it could be investment banking in the algorithmic trading side. Customer retention, risk analysis is becoming more and more important in the industry today, particularly since all the folks who were doing a lot of this portfolio prediction screwed up, and now they're all worried about risk analysis. And then a very big area is fraud detection, particularly in our banking environments and our insurance environments, and this is becoming more and more important. Now, so what's interesting is if I go back to my retail banking contacts and I go, hey, do you do any analytics? They would go, oh yeah, and they do a lot of these things in the banking environment. In fact, here, well, before I get to that, this is the iLog Cplex. This is the operational research optimization kinds of things. And so here you see shift planning, portfolio reshuffling, resource allocation, routing, scheduling, campaign optimization, cash distribution. We actually have some banks that are going to be using iLog Cplex to do trade settlement between banks at the end of the day and to figure out the optimal way to move the least amount of money and make sure that all the accounts are settled. So this is I showed you SPSS before, and this is the iLog C-Flex optimization. So here's an example for the SPSS 7 analytical functional areas I told you of how it fits into the commercial environment. Here's core banking, for instance, and in core banking you have multiple different kinds of solutions: customer insight, product recommendations, fraud detection, prevention. And then over here, let's take fraud and prevention, or fraud detection. That breaks down into some lower level functional areas. Fraud detection, risk analysis, and collection analytics all make up this solution right here. You'll also see further down, under financial markets or under insurance, you'll see collection analytics or risk analysis show up in many different places. So it's not a one-to-one relationship. Those 7 functional areas are spread across multiple different solutions, and this is just for the financial services segment. I've got this for retail, telco, healthcare, and so forth. I don't want to bore you with chart after chart, and I've got it for SPSS, and I've got it for iLog. So now let's go back to fraud detection, which we also said included risk analysis. And so that breaks down into some lower level analytic functional areas like classification, clustering, prediction, anomaly detection. And up here we have some algorithms. So in this case, we have support vector machine. We get up into risk analysis. There's nonlinear time series, logistic regression. You'll see neural networks show up here. And so now you start to see a lot of kind of statistical analytical algorithms that are part of fraud detection, that are part of actually a commercial solution. And so if you look at these algorithms, they're mostly double precision floating point algorithms, compute intensive, that now people want to do as part of their commercial retail kinds of environments. So I like to point out when I show these charts to IBM audiences, particularly Z crowds, that most of them, when they took computer science courses some years ago, they took their algorithm courses and the math behind those algorithms, and then they spent the rest of the years doing IMS debit credit. And so I'm pointing out that debit credit's about to get fun and interesting again. So here's an example of a credit union on the West Coast, modest-sized credit union, not a particularly big credit union, and how they use analytics in their day-to-day business. So the first thing they want to do is they want to minimize the number of branches they have and the number of people that they need to employ to have one-on-one customer interactions. And so they've been setting up kiosks around the city where people can go and do their banking, and people will want to get cash out of it. And so some people have had trouble with their banking experience in the past, and you might only want to give them $100 cash at a time per day. Other people, you can give them $1,000. So when that person goes up to a kiosk and makes a request for funds, they have a scoring model, and I'll talk about scoring and define that a little bit more, but they have a scoring model that's embedded into the transaction where the person's trying to get the money. So this scoring model is a representation of a whole lot of work to statistical and analytical work to figure out whether this person matches certain characteristics within that model, and therefore whether we should give them money or not. This is analytics within a real-time transaction. Then they want to use it for targeted campaigns to improve retention and revenue. So companies aren't doing mass mailings anymore. They're doing very, very targeted mailings. They've clustered all of us into different behavior groups. And now they want to do certain mailings to maybe just those behavior groups. So they're trying to optimize the amount of money they spent on their marketing and get more return for that. And so they're using techniques such as regression to create those profiles. There's a lot of modeling that goes into that. But they need to make that available to also call centers, such that when a customer calls in and they have a problem with a payment, or they want to complain, or they're interested in a loan, they can very quickly size that customer up based on these analytic techniques and figure out maybe we could offer this person one thing versus another. The other area that they're using it is They want to expand their customer base. So they want to go after people who many banks have refused to do business with because of their past credit histories. And so they, using, again, models and scoring models, are doing a risk analysis to say, okay, we can take on so many customers. We know some percentage of them will become problems, will cost us some money, but will make more money than we lose. And so they're evaluating those pros and cons in terms of, and really scientifically now, evaluating how much risk they can take and make more money. And then finally, they're using predictive models with factor and regression analysis to figure out when and where to build new branches. So this makes sense. Credit unions, banks should all be doing these kinds of things. Some are doing more than others. I think you're going to see that when people realize that some institutions are doing it, have a tremendous return on investment for their investment in their analytics infrastructure. Everybody's going to do this, and they're going to need to do it as this is just a requirement to do business. If you're not doing it, you're not going to survive. So let's take a look a little bit behind the scenes of what this environment might look like. Now this, I'm going to show you a representative picture and not the specific institution. And so behind the scenes, it's not the simplest setup. So up here, I've got their OLTP online environment. Hopefully it's on a mainframe. Maybe it's IMS, KIX, WebSphere, SAP, whatever that's generating mission critical online data that's being used, new orders, debit, credit, whatever that's coming into the business. And now we want to start to get some insight into that data. So the one step in that now is to take a copy of that data, possibly transform it, extract it out of there, and then load it into another platform where you have a warehouse. Now that transformation process in and of itself often goes to yet another distributed platform. Whoops. I'm just going to turn this off. Goes to yet another distributed platform to do the transformation. Then we move the data again down to the warehouse and yet another platform. And now we've got this warehouse. We start doing some heavier queries against it, maybe some data mining kinds of things, business intelligence kinds of stuff in quotes. But we also start now running reports against that data. So we have products like Cognos that will start running reports against this information. And then you'll have a line of business that said, I need to look at a subset of the data. I need it structured in a different way than the way it's in the warehouse. So I'm going to create new tables from other tables. I'm not going to include some columns, and I'm going to add some columns from that table. And so now you're going to transform it again into data marts. So on yet another platform, another data repository, back through here. And then finally you get to the point where you want to do modeling. And now you're going to use perhaps the data marts for your models, maybe the warehouse for your models. This is yet another process. This is where now you do your deep modeling and analysis with things like SPSS or iLog. And then from that analysis activity, you now generate, you take an abstract of the learnings of the model, you create a scoring algorithm or a business rule, or sometimes a combination of both. And you want to drive that back into your OLTP environment, so the next time a person contacts the system, you now can start to do some real-time analytics or response to that person contacting the system. So this is, we've defined, we've articulated this life cycle, and now what we're looking at is all the complexity that's inside of it. When I show this to customers, they go, yep, that's us. And they can say, you know, we think we have the fastest warehouse, we have the best queries per second or the queries per dollar, but you know, my real problem is just getting the data around this life cycle. It takes forever. And I go through all these different places. If I have a failure, I'm never sure. I've had more than one customer tell me that it takes, one customer said, 10 days out of the month just to figure out if the data that they have is accurate. So the accuracy of the data, the cleansing of the data, having the right data in the right place at the right time is a huge challenge in this environment. So our strategy in the Z world is to try to simplify this. So the first thing, of course, is we need the portfolio of products on the platform. And so assuming we've got a lot in the OLTP space, we now have InfoSphere InfoServer, which is data stage, which is an ETL, an extract, transform, load product that does that transformation into the warehouse. We've got, of course, your warehouse. These both are running on zLinux. We've got Cognos on zLinux and just recently announced on zOS. We've got SPSS and iLog on combinations of zLinux and zOS. And so we now have the portfolio there, and we're continuing to build on that. And now the question is, how can we manage this life cycle with less data redundancy, less data movement, reduce the complexity, and provide a more accurate environment that's more secure and also more available. So we can look at one hand how to optimize a double precision floating point neural network algorithm. On the other hand, we've got to look at all of these kind of environmental issues to make sure that that all works together. So this is a definition of predictive analytics from SPSS. And I happen to have obviously access to SPSS, but SAS, there's a number of other vendors in this space, and I'm not trying to push one product or the other. But I like the definition, and I underlined and highlighted a few of the words, because it says data is part of it, decision making is part of it, statistics is part of it, and process is part of it. So we've got to look at all those pieces and optimize all those cases. So again, it's, predictive analytics is business intelligence technology that predicts what's likely to happen in the future by analyzing patterns in past data. Predictions are delivered in the forms of scores, as I talked about, generated by a predictive model that's been trained through a multiple iterative process on historical data. So we need to have that historical data accessible to us. Assigning a predictive score is the job of a predictive model which has been trained over time. And then there's this cumulative experience that's used to essentially improve and enhance that. So I'm not sure. So the world is full of data. Generally, within an enterprise, you only have a subset of that data. You have data that you're interested in, and you never have as much data as you would like about your customers. So, so we use applied mathematic techniques to try to generalize about the data that's in the universe for our specific purposes within our enterprise. And so we're trying to we try to go after many different kinds of data. And so traditionally, we've gone after descriptive data, attributes, characteristics, where do you live, how much do you earn, how old are you, what's your behavior like, what kinds of things do you tend to buy, what's your usage history, how do you interact with our institutions, and so you're interested in behavioral data. Then there's more and more, you're starting to look at interaction data. Companies are developing huge repositories of email, of chats, of text summaries of calls with a customer. So you need to be able to go and look at more text-related kinds of data. So there's text analytics, and you want to be able to look at that text within context. You want to just not know that a word was used, but you want to know the context in which that word was used. And then you're starting to see attitudinal data. And this is looking at the social networks. What are people saying about your company on Facebook? What are people saying when they go to TripAdvisor and they rate your hotel and they don't like it? It's got bed bugs. You want to detect that kind of stuff quickly and then be able to respond to it. So all of these different inputs of data are also an important part of the analytics environment. So we take that data and then we start to look for patterns, and this is this iterative modeling process. And the predictive model might now identify some attributes. You're married, you got a kid, you live in Chicago, you've got cars, how old are you? And you drink scotch. Now your attributes are, you like Guns N' Roses, we know you like Johnny Walker Black, you commute, you work a lot, and then we can now, from this analysis, based on what other people who have similar attributes as you, in similar behavioral case as you, we can predict, we can predict what your behavior is going to be. We think you're going to want to buy a sports car, or you might buy some Chardonnay. You want to go vacation where it's warm. So this is the kind of things that, that are happening behind the scenes in these analytic environments. So now you've got your predictive model. and you understand what a particular individual may do the next time you interact with them. And there are actually a number of different touch points. I've been focusing on individuals and kind of customers. So a customer calls up, and now the person who's sitting in the company has this information accessible to them. A score is done while that customer's on the phone, and this person in the company has a sense of what they should do relative to this customer now, based on these scoring algorithms that come from the model. You may have no humans involved at all. You may have, in terms of the decision-making process, they're interacting with your systems. The systems are making dynamic decisions right there. They're scoring you. A decision is made. And so both of these environments are very common. So again, as an overview of kind of the predictive analytics world, it's broken down into customer analytics, acquire, grow, retain your customers; operational analytics, manage your business, maintain and maximize your profits, make things as efficient as possible, reduce your inventory. And then you've got predictive threat and risk analytics, monitor what's going on, detect a threat, control it, fraud detection, and so forth. Those things in the commercial space tend to fall into those three areas. Underneath, data collection, as I talked about earlier, was very important. Many, many different sources of data are required, more and more over time. Statistics, the whole modeling infrastructure, and then how does that all fit into your decision management process? So now I'm going to shift from a higher level, kind of what predictive analytics is, to what does it mean for System Z and the kinds of challenges that we're looking at. So as I got involved in this, I made myself this chart to kind of understand all the things that we needed to think about in this space. So some of this was for self-education, and I validated to some extent with a number of others. But you have many different workloads. From left to right, you have some, and this is a very approximate chart. You have your OLTP environment. Within that OLTP environment, you may do some real-time scoring. You might do some near real-time batch processing. And then you work your way towards ad hoc queries, then data mining, and then modeling. And you go from production reporting to interactive reporting to kind of predictive kinds of activities as far as your workload is concerned. Well, these different activities will go against different repositories of data that have different time considerations. OLTP is your most current copy of the data. That's the last committed data in your institution. You may have an operational data store, which is a recent copy of that data, but it retains the same kind of structure, but you've kind of culled or trimmed down your online environment so that you can maintain the performance here. And now you can start to do a little bit more kind of reporting against this kind of area. Then you have less recent copies all the way to historical data that could be very cold that you look at very infrequently, but you need it, particularly if you're going to do modeling. How much does the data transform? Well, you don't transform the original copy, but when you do your operational data store, it may just be a copy. You might just do a flash copy or just don't change it at all. You don't cleanse it. But as you move towards the right, you, in addition to copying it, you're cleansing it, you're aggregating it, you're transforming it. You may be changing it from an online schema to a star schema. And then as you get over to data marts, you'll start to get into even more complex transformations. How much detail is in the data? And there's not consensus here. I'm not sure I have this quite right. But certainly in these environments, you've got all the detail in the data. When you start to do aggregations and create warehouses, sometimes there's certain data that you decide that you want to toss out, you don't need, or you summarize in various ways. And then you get to less detailed data. Now what I'm hearing is, that's why I have an asterisk, is more and more people want all the detail they can get. So we now need to have more detail over in these environments where we may not have in the past, particularly as we get into modeling. Query scope. In the online environments, you're often looking at one row at a time, or a few rows at a time. And as you work your way over and start to do reports, multiple rows, multiple table scans, or table scans, multiple table scans, so the scope of the query in terms of its breadth can vary. Data access, the OLTP environment is optimized for read, update, insert, delete. That requires certain kinds of indexes and certain kinds of optimization. DB2 ZOS is very much optimized for this kind of activity. This is what B tree indexes are for. Then you get into read-only environments, and I always had read-only environment over here also for modeling and some of this analysis, and customers are telling me, no, we're doing some updates in that area too. As we do the modeling, we're pushing stuff back in. Data manipulation and computation. Very, very light in the OLTP environment. As we start to do real-time scoring, we might see some medium numeric activity. So these, you'll see some double precision floating point in here, but it's pretty light. It's not very heavy. Data intensive, and then as we work our way to the right, you see varying mixes of data and numeric intensive processing. Depends on the algorithm, depends on the model, but you need to be able to, it gets more and more active to the right. And then the number of users, you go from thousands of users to a smaller set of users. So these characteristics are, I didn't put them purposely into columns because there's certainly no clear boundaries. So if you look at in the industry, in DB2 ZOS, for instance, we've optimized very much for the left side of this picture. That's where DB2 ZOS strengths are. What you see on the right side of the pictures, you see things like Teradata, Green Plum, VectorWise, Netezza, which IBM has now acquired. SAO actually is an old acronym for something I'll talk about more in terms of Netezza technology integrated into the Z environment. But they've optimized for this side of the picture. They do not do update, insert, delete. You don't want to take one of these appliances and just access one or two rows at a time. And so the question is, these guys are trying to expand their capabilities to the left, and we're trying to expand our capabilities to the right, and how do we integrate these two technologies in the most optimal ways? So we have some existing advantages with Z. I talked about earlier that we've expanded our business analytics portfolio, and we're bringing more and more onto the platform constantly. In terms of Z196 and the Z hardware, Z196, we've doubled our floating point performance from Z196 versus the previous Z10 system. We've had a tremendous amount of emphasis internally on our compiler, C compiler performance, Java compiler performance, using new instructions in the instruction set architecture. And as we look forward into future systems, focusing in on compute intensive performance so that we can do some of those algorithms that I talked about earlier is a high priority for us. I'm going to talk about in more detail in a minute something called the IBM DB2 Analytics Accelerator that uses Netezza technology and how we're integrating that into the system. We've been using DB2 ZOS data sharing so we can have OLTP logical partitions. We can have query partitions or warehouse partitions, and there are techniques that are used such that you can do both against a single copy of the data and yet not interfere with the performance of the OLTP transactions while you're trying to run your heavier queries. There's more work that we're doing in that area, but that's also something that we talk about and we leverage. And then finally, new in the last release of DB2 version 10 is something called bitemporal functionality. And there's DB2 on ZOS has a leadership position in this. But this is basically allowing us to do queries as of a particular point in time. It facilitates that. So we actually add a couple of columns that keep track of timestamps. So every time a change is made to a record within a row, we are actually creating a new row and putting timestamps into those columns. And so we actually have now historical data essentially integrated into the OLTP database. And there's and this facilitates doing SQL to do a query, for instance, what is my position at the end of the day or end of business, for instance, as of 5 p.m. And so that's been a big requirement of customers. It's a complex process to do that. And so this temporal data functionality makes that easier to do. I'm going to skip over a few of these for the sake of time and go to this chart. So what we're seeing from a Z design perspective is that the OLTP environment is evolving. So what used to be a simple debit credit transaction now is going to have much more complex processing as part of that OLTP transaction. So I talked about fraud detection a lot. We did an experiment actually with a cell processor some years ago, working with a fraud detection vendor with their software. And we said, the cell processor we actually did a test. We can do these neural network algorithms very, very fast, orders of magnitude faster than we can do it on Z. But the latency overhead of getting out over a network to the cell processor and bringing it back, relative to the amount of processing that you do in a scoring operation, it just didn't make sense. So we said, we can't rely on an attached accelerators to do this real-time transactional scoring. We've got to optimize Z itself to do that. So that's why we've been focusing significantly on the Z instruction set architecture and on the compilers. So we are focusing very much on doing scoring and analytics within the scope of a transaction and optimizing the infrastructure to do that. We're bringing the SPSS scoring infrastructure, and we're going to be running that, I'll talk about later, within DB2, ZOS, and I have some charts on that. Same with ILOC. The other end of the spectrum is bulk data analytics. So this is real time in a transaction. This is more of a batch, not real time environment. There are various time requirements for how often that batch job runs or what the response time needs to be. But now we're going to be doing more work within the scope of a query or a modeling process. And this is now where attached acceleration can play a role. And so with the IBM's acquisition of the Netezza technology, we are doing a number of things here to integrate that Netezza technology into our Z environment so that we can do the modeling and some of the heavier aspects of processing related to analytics. So this requires a good hardware accelerator, such as Netezza, where we need a good transport between here in terms of network. So we're working on something called remote direct memory access, or RDMA, that allows us to move large amounts of data with very few CPU cycles with extremely good latency. It comes from the InfiniBand world. And then IBM is putting a lot of attention into continuing to enhance the number of algorithms that are part of the SPS libraries and coming out of research. Again, these are the two ends of the spectrum that when we're focused on both of them. So here's a simple scenario. You have a telco, and customers, they're looking at how their customers are using the smartphones, and they're looking at what applications they have, and they find that there's patterns when somebody has one application, they're likely to have another. And so they're building a predictive model to recommend applications based on what other users like you have used in the past. And so they do the modeling, and then they do the scoring when you interact with them. So there's a very simple picture. They're browsing applications. You're doing a score of the kinds of things they're looking at. You know what's already on their phone. And you basically then, you make a recommendation. Prior to that, you've done modeling over here to figure out what that scoring algorithm is going to look like. And then eventually, you start to get changes in this information. People start buying a number of applications, or new applications come on board. So you need to be able to refresh those models on a regular basis. Sometimes you start from scratch and you do model creation. Other times you do model refresh. And then you want to be able to update those scoring algorithms also as efficiently as possible without having to essentially change your application. So I'm going to talk about what we're doing to optimize this space and what we're doing to optimize in this space. So this is batch and near real-time analytics. I'm going to start actually with the modeling side of this and the warehousing side of it. And I'm not sure how familiar you are with something that we call the Smart Analytics Optimizer. I don't know if Jeff talked about that in the previous presentation. But we came out last year in the ZBX, on the blades within the ZBX, with an appliance that was designed to do high-performance queries. And it was called the Smart Analytics Optimizer. The technology inside came from IBM Research. It was using a number of parallel processing techniques. It was using in-memory capabilities and compression to provide extremely fast queries. We were seeing queries going from 30 minutes to a second. Now, the challenge with it was It was very fast when you hit the sweet spot. Sweet spot wasn't big enough for many of our customers. And then just as we GA'd that, IBM bought Netezza. And we then did a deep dive into Netezza technology and decided Netezza had a much broader sweet spot. It wasn't always as fast as our first version that we built in-house, but you're trading in extremely fast queries for a very small working set, for very fast queries for a much broader working set, plus it was a more mature solution in many ways. And so the design point that we had for both cases was queries will come into DB2 ZOS. The DB2 optimizer will decide this query has the kinds of characteristics that are best run on an accelerator, or this query is only going after 1 or 2 rows where we've optimized that for DB2 ZOS. We're going to keep that one close. So we took the same design pattern. We replaced the Smart Linux Optimizer version 1 with the Netezza technology here. The only difference is and we called it IBM DB2 Analytics Accelerator. The only difference is it's not inside the ZDX. So here's a look at Netezza technology. Yes.
Does DB2 make that decision on itself, or do you provide it rules about characteristics of a transaction?
The DB2 optimizer will make that decision. Okay. Now you'll decide what data, you may decide which data you would like to have replicated in the accelerator. Mm-hmm. So that you'll have some tools to help you say, these are the tables that we want to have replicated over there. So all the data that's in the accelerator is actually a copy of data that's also in DB2 ZOS. Now theoretically, if the IDA box were to go down, you could continue to run all those queries against your Z system. But that's done by the optimizer.
Let me ask you something. And we're talking always about, let's say, optimization of relational database management systems, pretty much. So when you refer to the data warehouse, you're referring to mostly a relational data warehouse, huh?
Correct. Yes. Okay.
Because IBM, they purchased Cognos, and within Cognos there's a tool called TM1 that has been running in memory a lot forever, and that's great technology. So.
Right. Yeah, so I actually had a picture of an in-memory cube in my early complexity picture, but that's a reference to things like TM1. We actually have 2 or 3 different, cubing technologies within within IBM, but the TM1 is certainly a prime example. We're just now porting that to zLinux, and we're looking at how best to again integrate that into our simplified framework.
That's very interesting.
Yep. So quickly, I'm going to give you a little bit overview of what Netezza does. So the first thing is, there's a lot of things inside of this, but from your perspective, it's like a washing machine. You buy it and it has some buttons on the outside. It's an appliance. You don't buy so many of the disks and so many of this and so many of that and put it together yourself. You buy a box. Inside the box, you have disk. You have a couple of SMP hosts. These are x86 processors. You've got basically 2 of them in a kind of a pizza rack kind of format. And down here, you've got these what they call snippet blades, and then I'll describe them in a minute. But these are IBM x86 blades and a blade chassis. So one of the reasons this Netezza acquisition was very nice is they actually were using inside a lot of IBM componentry. So I'm trying to remember the sequence here of my charts. So just these blades down here, normally an x86 blade is a single wide blade, but these are double wide blades. And in fact, they're called twin fins. They're on a hinge. So you have your x86 motherboard and all the stuff that goes with that in one blade. On the other blade, you have a bunch of FPGAs, or field programmable gate arrays. Is everybody familiar with FPGAs? So an FPGA is a chip that has a lot of transistors on it. And those transistors essentially provide you logic gates or logic elements. And unlike other chips where somebody has decided what each transistor is going to do and essentially hardwired that behavior, with field programmable gate arrays, you can program these transistors or logic elements to do whatever you want. You can make an AND gate, an OR gate, or whatever, And so now you can lay down on these chips that are heading towards 700, 800,000 logic elements on a chip. You can do a process that may have been done in software. You can program to do that now in hardware, and you can do it very, very fast. And so they are combining, and I'll show you how they're doing it in a minute, but they have FPGAs now combined in these twin fin blades with x86 processors. So let me just talk about the right side of this picture. Ignore the left side for the moment. This is the inside of the IBM DB2 Analytics Accelerator with the Netezza technology. And we don't want to call it Netezza, but there's, for reasons I'll explain in a minute, but if you look at it, there you have, within this snippet processing unit, you have a CPU and an FPGA. There's actually multiples, but there's a one-to-one relationship between each CPU has an FPGA, and each pair of these, or I should say each CPU and FPGA has a disk. And so you have this massively parallel processing environment with scale out, where this CPU is only accessing this disk through that FPGA. You have SMC controller host right here. Over here you've got your DB2 ZOS. So here the request comes in, goes to the optimizer. The optimizer says run it in DB2. It does a cost optimized analysis, or it sends it over to the IDA box. There's interfaces that we've built here such that this box here will only be accessible from DB2 ZOS. You could buy a standalone Netezza box, but it would not have that kind of integration. And you'd have to decide on your own what data to put over there, what queries, what workloads, whatever to move over there. You have to manage it as a completely independent environment. What you have here is a query comes in, single point of entry. Underneath the covers, you have workload optimized systems that are doing best fit for purpose processing for the particular nature of that query. So here's how so one area of acceleration is just coming from this massively parallel approach. And there's a lot that, on lower price commodity kinds of components. The other area, and this is how they use the FPGAs. When they read data off a disk, the data on the disk is compressed. They then use the FPGAs to fluff or decompress the data and blow it up. Then they use the FPGA to do what's called projection, or actually to strip out the columns that aren't part of the query. And in fact, what we often see is tables with many, many columns. We're only using 3, 4, 5 of those columns. So right now with DB2 ZOS, if we want to look at 3 columns out of a 20-column table, we bring in the whole table, or the whole row, I should say, and then we throw out most of it. So in the FPGA, they throw out the columns before it even gets to the processor. Then they restrict the variability, so they take the where clause and basically they go, what rows match my criteria for the columns that I've selected? And so now you have a much smaller amount of data that finally makes it over to the CPU that's in the snippet, or in that twin fin that's in the snippet. And so the amount of data that actually gets in here is much, much less. And then the processor does the joins, aggregations, or whatever it does in the query. And when this is running flat out and it's pulling data off the disk at 100 megabits per second, these CPUs are only about 25% busy. Because they've essentially offloaded an awful lot of the CPU cycles that are being done by traditional database processing. They're doing it in this hardware, this programmable hardware. But they don't, it's once they program it, it pretty much stays the same, but it allows them to have flexibility. Running the Raven Hunt. So there's just some, I've talked really about, I think, about money and benefits, but the main thing is that this IDA accelerator is under the covers of DB2, is managed as part of that DB2 ZOS security environment. The operational controls in terms of backup and recovery all managed from the DB2 perspective. And we just had a big conference on the West Coast last week called Information on Demand. 11,000 people were there, and this was very, very of great interest. One of the customers, 2 customers presented the results. One got 90x performance improvement compared to running the query on Z. One actually running one query at a time had queries getting 1,900x improvement. I, as a performance guy, am a little suspicious of that in terms of their baseline measurement, but it doesn't matter. They installed it in 24 hours. 24 hours later, they had their measurements, and they didn't, nothing mattered after that. In fact, they were running queries on their test system, and they were calling up the folks who were running the production queries on the Z system and telling them what their answer was going to be. And so I'm going to build this up quickly. This is a chart from NetEasa, and this is a future directional discussion I'm going to have here. This is the analytics, this kind of the software analytics infrastructure that's in NetEasa now. So they support things like Project R or R language.
Yeah.
So this is an open source statistical programming language. They're going to be supporting Hadoop, MapReduce kinds of things. They have a whole library of things like user-defined functions, user-defined expressions, and so forth, which I'll talk about a little bit more. They have their own library of algorithms, but we're putting SPSS into it. SAS has a relationship where SAS is running a lot of their analytics here also with their own algorithms. And so what this is saying is that when I want to do things like modeling, where I want to look at a lot of data, I'm doing queries and computation, this is going to be a very attractive platform to do that. Now, right now, we haven't integrated because we're actually just GAing our first IDAAs at the end of this year. But the next phase in terms of what we're looking at is now how do we incorporate the modeling into that DB2 ZOS environment along with the other things that we're doing. And I'll talk about the operational scoring in a minute. So this is a really interesting direction we're going to go. And when we can combine this with our DB2 environment, I think we've got a very interesting story. Next topic is real-time transactional analytics. This is some work we're doing with SPSS. I'm going to skip over this chart quickly. Right now, SPSS runs on zLinux. So if you've got an IMS KICS transaction, let's say, that wants to do a score within that transaction, you have a few choices, but one is you get your data out of the database, you then send it over a network to Linux or to a distributed box, you do the score there, you then send the answer back. So customers are saying, how do I, we wanted to demonstrate that we could do this with our IMS and KICS, but then we said, there's a better way to do this. DB2 has functionality called user-defined functions that they've had for some time, that basically allows the customer to define some of their own function, but invoke it as an SQL statement. And it runs kind of like a stored procedure call or within an address space. It's workload managed. And so what we're doing is we're porting the SPSS algorithms into a user-defined function that will run inside of the DB2 database, and we're going to avoid the need to call SPSS on another platform or to do that score external to the actual contact with the data.
Is that similar to what Microsoft does in analysis services? Microsoft extended SQL into some kind of strange SQL/data mining language that pretty much embeds data mining within SQL.
Yeah, I'm not familiar actually with exactly what Microsoft is doing, so I can't comment on that. But this is not unique to us that we're doing it. Although most of the time, what I've seen as we've been implementing this is most customers are still doing their scoring on a separate platform. They're invoking it remotely, and they're also they're focused on batch scoring. And my view was, as a strategist in this space, is if we've got the online data, let's integrate this as close as possible or as much as possible into that OLTP environment. So this is just some very early performance measurements, and I won't. So basically, what we did is we compared the distributed score approach, SPSS scoring on zLinux, with doing the same thing in a user-defined function. We used a logistic regression algorithm, and we did a neural network algorithm. But basically here you see for one case, in this case, basically one comparison, we went from 414 trans to 1,700, about 4x or so improvement, and the response time was cut by more than half. And this other case here, we improved by about, I think it's 7x, I think it was, and we went from 7 seconds to a second of response time. So, so this again, as I started off with, what is predictive analytics? But then as we work our way down, this is the kind of thing that we're looking to optimize. Now within that, we're also optimizing the algorithm itself in terms of the computation, and we were able to do, I think we did logistic regression with 66 parameters in well under 100 microseconds kind of thing. So, but this is the kinds of things that we're doing. So there's a lot of advantages within database scoring. For time, I won't go through it, but if they're fairly self-explanatory, you get a chance to look at the presentation. So let me just move on. This is a directional chart. A lot of this is in place, but not everything is in place. But what I've been talking about is kind of going from an OLTP perspective on the world to an OLTP perspective of the world, where we're integrating analytics into our transactional and online environments. So what you have up here is an existing picture of parallel sysplex DB2 ZOS with your OLTP partitions or members and your warehouse members over here. We can do the real-time transactional scoring, as I just showed you, with user-defined functions right in here. We then use the ETL or ELT to create our enterprise data warehouse and our query member within the sysplex. And here we have the option if we want to do batch scoring here, also using user-defined functions. We might do a little bit of model refresh, but that'll probably more likely be done down here in the IDA box using the Netezza technology. So we're now, again, with this integrated environment, we're able to manage many aspects of the life cycle of an analytics, predictive analytics business. And then we've got a number of products that are running on combinations of zLinux or ZOS that provide input, drive work into that infrastructure. So I did not show you everything, but what and there's actually more circles on here that I took off for this presentation, but we're doing a lot in the Z and the DB2 ZOS side to enable us to reach more over here to the right side. But the IDAA with the Netezza technology is allowing us to also reach out over in this way, and so we have an overlap of circles in the middle, and that overlap and continuum we see as a very positive direction. So, summary chart. We are building the blocks that we need to evolve OLTP to incorporate analytics function into our OLTP environments. We're doing much more with the most recent copy of the data rather than have to copy everything off and do all the analytics on flash copies or older versions of the data. We're embedding scoring into our transactions. We're enhancing our sysplex technology to facilitate concurrent query and OLTP activity. I didn't talk about it today, but we're doing things to enable more complex queries in the OLTP and operational data store environments. We're exploring FPGA technology on the Z side also. There's a number of potential areas where we could be using FPGA to accelerate some of our computational plumbing, so to speak. And then we continue to look at the ways of enhancing our instruction set architecture, or ISA, to facilitate some kinds of data-intensive processing, but also a lot of the computational intense processing. And then finally, we're using the IDA technology as a embedded, fit-for-purpose capability within the extended zEnterprise environment. So, I rushed through a lot of things. There's some areas where I would have liked to spend some more time, but I want to leave some time for questions. And what do you think?
Good. Any questions?
No. I have a myriad. I can spend the next hour asking, perhaps. Well, it was good news that you were mentioning that TM1 was going to be meant. Actually, it's my first chart when I do my
okay.
presentation.
Uh-huh.
The fact that TM1 is being migrated. There was some comments about a year ago that TM1 was being. TM1 has always been a kind of Windows/regular Linux
Right.
platform.
Yep.
And there were some comments that it was going to be migrated to the mainframe, pretty much.
Mhm.
So that's happening at this point, and
Yes.
that technology is being
Yeah.
evolving.
Yeah, so there's a number of interesting things in that area, not just with TM1, but cubing technology. So I would be interested in the kinds of use cases that you're using for that, and
Mhm.
how it relates to back-end work on Z and DB2 is one. One use of cubing technology is kind of a front-end dynamic cache, so where you can satisfy a lot of the queries in the in-memory cube and not have to actually go back and access the data in DB2 itself.
Mhm.
So that's an area of interest where actually I've been wanting to do some experimentation. The other thing I'm interested in is if we were to provide an in-memory TM1 cube, let's say, it can be resource intensive. Needs a lot of memory,
Yeah.
maybe a lot of threads.
Mhm.
And so someone might say, that's too expensive to run on Z. And I would like to be able to provide some in-memory cubing technology like TM1 as an appliance.
Oh, yeah, I would think about
It's
that,
actually an
exactly.
appliance, it's actually a software virtual appliance that's running on the Z hardware at a different price point.
Okay.
So, finding the use, with all of these ideas, it's always the key thing is to find the real use case that would justify that kind of a direction and ultimately investment.
So the other point is embedding SPSS as part of DB2 in a certain way. There is
Yeah.
some direction.
Yes. Yep.
Okay.
There's a whole another area of analytics that I did touch on called big data.
Yeah.
That's a whole nother discussion, but I'll just mention it very briefly. Within IBM, when we refer to big data, we're really referring to two technologies. One is MapReduce Hadoop, and the other one is something called infosphere streams, which is really dealing with very real-time streaming data coming into your computational environment, and essentially windowing that data as it goes through, looking for anomalies, making some real-time decisions perhaps in terms of routing and so forth. And so there's a lot of work within IBM to look at the combination of infosphere streams and Hadoop MapReduce. We're trying to understand where within the zEnterprise configuration that also would fit what the use case scenarios are. So that's another area.